Welcome to Serenity, Game Systems Foundation. In the previous video, we continued integrating Serenity into our small runner game. But there is still one important part of the original game that is completely hard-coded, the player input. Right now, the player jump is being read directly from keyword inside the gameplay script. That works for a small prototype, but it does not scale very well. In this video, we're going to replace that hard-coded input logic with Serenity's player input system. The goal is simple. We want a player to keep jumping exactly as before, but instead of the player jump controller deciding which keys are valid, Serenity will receive the input action and invoke the gameplay method for us. By the end of this video, the same jump action will work with keyboard and gamepad, without hard-coding the input device inside the player script. In the current version of the game, the jump script is doing two different things. First, it contains gameplay logic. The player can jump only when grounded, and when it jumps, we apply an upward velocity. But it also contains input reading logic. It checks if the player presses space, up arrow, or W. That means the gameplay script is coupled to specific device and to specific keys. For a prototype, this is fine, but once the game grows, this becomes a problem. What happens if we want to support gamepads? What happens if we want to remap controls? What happens if we want the same gameplay action to be triggered from different input devices? Instead of making each gameplay script read raw keyword or gameplay input directly, Serenity can listen to an input action map and invoke a method when a specific action happens. So the gameplay script only exposes the action it can perform, in this case, jump, and Serenity is responsible for connecting that action to the configured input. This gives us a cleaner separation. Input configuration belongs to the input system. Gameplay behavior belongs to the gameplay script. Let's open the current player jump script. In our project, the jump is handled by player jump controller. Right now, the script looks like this. The important part is this one. And then we have this method. This is the part we want to remove. The player controller should not care whether the input came from the space key, a gamepad button, or any other device. It should only expose the gameplay action, jump. So we are going to refactor this script. First, we can remove the jump press method completely. This method is reading directly from the keyboard, so it's no longer needed. Now we are going to rename update to jump, but this is not only a rename. We are also going to remove the jump press condition. Now the script no longer checks if a key was pressed. It simply performs a jump when somebody calls jump. That somebody will be Serenity's input action invoker. This is much cleaner. The player controller is now only responsible for player behavior. The input mapping will be configured from the Unity editor. Now let's go to Unity. We select the player prefab. With the prefab selected, we add a new component. Search for input action invoker. This component is part of Serenity's player input integration. The job is to listen at a specific input action and invoke a method on a target component. So instead of writing input polling code manually in update, we can configure the connection directly from the inspector. In the input action invoker component, we first assign the input action map. This is the asset that defines our gameplay actions. In our case, we need the action map that contains the jump action. Once the action map is assigned, the component can show the available actions. Now we can choose the jump action. This means the invoker will listen to the specific input action. The important idea here is that the action itself can be mapped to different devices. The player script does not need to know any of that. It only receives the final instruction, jump. Now that the input action invoker knows which action to listen to, we need to tell it which method it should call. In the method section, we choose the player object as the target, then we select jump. This is the method we created before. So now the flow is, the player presses the configured input. The input action map receives the action. The input action invoker reacts to the jump action, and finally it calls player jump controller.jump. At this point, the player jump is fully connected to Serenity's player input system. Now let's enter on play mode and test it. First, we test the keyboard by pressing space. Next, we test the gamepad pressing the south button. The behavior shall be exactly the same as before, but the internal implementation is now different. The player controller is no longer pulling the keyboard every frame. We changed the input architecture without changing the actual gameplay behavior. The game still feels the same, but now the input is much more flexible. And this also means that future changes will be easier. If we want to add mob devices, remap buttons, or block players' input in certain game states, we can do that through the input system instead of modifying the player controller. And that's it! In this video we replaced the hard-coded input logic from the runner game with Serenity's player input system. We removed the direct keyboard pulling from the player jump controller. We exposed a clean jump method. We added an input action invoker component to the player prefab, and we connected the jump action from the input action map to the gameplay method. The important thing is that the behavior of the game did not change. The player still jumps as before, but now the input is properly separated from the gameplay code. That makes the project cleaner, more scalable, and easier to extend. In the next video, we're going to continue polishing the integration. Now that the game flow, audio, modals, and input are connected to Serenity, we can start customizing the visual elements to make the game feel less like a prototype and more like a complete experience.